Hi, this is Math 1340, and this video is over section 1.5. We're going to have two parts of this. The second part, we're going to get into what's called a quadratic function, which is a way to solve quadratic equations. First part, we're going to look at three other ways of solving it that are useful in certain instances. So a quadratic equation has the form ax squared plus bx plus c, and it's set equal to 0. If it's not set equal to 0 and it's set equal to some other number, we can subtract that number over and set it equal to 0. And then we look at solving these. Quadratic function is when f of x equals ax squared plus bx plus c. And when that is set equal to 0, you get your x-intercepts, which is the main reason why we look to solve these equations set equal to 0 is because we're going to look for x-intercepts. So the first method is the principle of zero product. This is a factoring method where we take a trinomial, like we have a trinomial ax squared plus bx plus c, and we break it down into two binomials multiplying each other. Now we'll call these binomials a and b, and so if they're set equal to 0, then the only way that happens is if a equals 0 or b equals 0. So when x squared minus 10x plus 9, this factors down to x and x. And then to get 10 from 9, factors of 9, it'd be 9 and 1. And since 9 is positive and 10 is negative, they're both negative. And so x minus 9 equals 0, so x equals 9. X minus 1 can equal 0, so x equals. So there are two answers here. Quadratic's going to have up to two answers. They could have none and you get just complex answers, or they could have one, or it could have two. Principle of square roots happens when there's no bx term. We just have ax plus c equals 0. And you're going to end up having x squared equals some constant k. And then when you take the square root, you get positive and negative square root of k. So x squared minus 16 equals 0. X squared equals 16. Take the square root of both sides, you get x equals plus or minus square root of 16, which equals plus or minus 4. And so let's practice some more. 4x squared minus x equals 3. Subtract over the 3. And then we can factor this. This will factor 4x and x. That'll give me my 4x squared. You could try 2x and 2x, but you're going to find that it wouldn't work. And then the 3 is going to multiply the x. The 1 for that factor is going to multiply 4. But we have 3x, 4x, and you got to get a negative x. So we're going to do negative 1 and positive 3. So 4x times negative 1 gives you a negative 4x. 3x added to that gives you a negative x. You can always just refoil to make sure it works. So 4x plus 3 equals 0. X minus 1 equals 0. 4x equals negative 3. So x equals negative 3/4. And x can equal 1. Okay. So now let's look at the same function, 4x squared minus x minus 3, as a function, and graph it. So f of x equals 4x squared minus x minus 3. We see we get 2 points. This is where they cross, 1, 0, and negative 0.75. And we can also see it crosses down here at 0, -3. The graph looks something like this. And so your intercepts are your solutions to the equation that we had of 4x² minus x minus 3. So your intercepts are -3/4 0 and 1 0. So they match what we found. -3/4, 1. Let's do another one. This one will go in factor. X² minus 10x plus 5 plus 25 factors into x minus 5 times x minus 5 equals 0. So x minus 5 can equal 0, and this is the same factor on both, so we don't have to write it twice, so x equals 5. So if we look at the graph, x² minus 10x plus 25, we graph and we see that it touches at 5, 0, the x-axis. So that's your solution. It only has one solution. And so the relationship between your real solutions to the equation, say equals 0, to the function, say equals 0, and the number of intercepts is that they are the same. Yeah. Another one, x² plus 5. We'll have x² equals -5, x equals square root of -5. Okay, this gets into complex solutions. Okay, we have two complex solutions, plus and minus. Plus or minus I square root of 5 is your complex solution. So you have no real solutions. That means no intercepts. So if we graph f of x equals x² plus 5, we see it never touches the x-axis. The lowest it goes is by 0, 5. It never touches the x-axis, so that you have no intercepts. So solutions to original equations, not real solutions. There's still solutions that we have to keep track of. Alright. Now we're going to get into completing the square. Increase this. Alright, so in completing the square, we do this a few times in this class for different reasons. It's really a method to try to solve it and without having to jump to the quadratic function, and if it's not factorable. So we don't really want to do this if it's factorable. Just factor it. But x² minus 10x minus 17. Do this. We're going to look at just the first two terms, and especially that 10x. And we're going to take half of that 10x. So that half of this is 5. And we're going to square it. And we're going to add it to both sides of our equation. So we'll have x² minus 10x plus 25, that's the 5 squared, minus 17 equals 25. We're adding it, plus 25, plus 25. And 25 comes from 5 squared, which is half of 10. Now, this x squared minus 10x plus 25, reason we do that is this becomes x minus 5 squared. We purposely are making that happen by squaring half of the middle term. We're making it follow a squared plus 2ab plus b squared. Okay? Which equals a plus b squared. Or if it's in minus sign, it's a minus b squared. Okay. Key thing to note, this sign is what's used in our x minus or x plus. So if it's a plus sign, that would be plus. And this number is what's used also. Okay. So you kind of know what it's going to be right at before you even do it. Now we solve this. So we'll add 17 both sides. 42. Take the square root. You get square root of 42, plus or minus. And then add 5 to both sides. You get 5 plus or minus square root of 42. Those are your two solutions. So I'll do a couple more. X squared plus 4x plus 1. Take half of 4, which is 2, and square it. You add it to both sides of this. Always add it right after the x term because it has to go together. This become x plus 2 squared. Then subtract the 1. Take the square root. Then subtract the 2. You have your two solutions. Okay. Now, not too bad when b term in the quadratic is even, but it gets a little harder when it's odd. Because you have to deal with a fraction. I would suggest keep it as a fraction. Don't do as a decimal at all, and just makes it easier. So half of 7 is 7 halves. We're going to square 7 halves. So we'll have x squared plus 7x plus 7 halves squared is 49 over 4 minus 1 equals 49 over 4. So we'll add it to both sides. Now this x squared plus 7x plus 49 over 4, this would become x plus, same sign, and again half of 7 is going to be 7 halves squared equals 49 over 4 plus 1. Okay. Now before we actually take the square root, we want to get come the denominator and get that fraction on the right side to be just one fraction. X plus 7.5 squared equals 49 over 4 plus 4 over 4, which equals 53 over 4. So now we'll take the square root. X plus 7 halves equals plus or minus the square root 53 over 2. And then subtract the 7 halves over. get negative 7/2 plus or minus square root of 53/2. But you can write it that way, or you can write it as one denominator. Either way is fine. Right. Couple more, then we'll be done with this section of the video. 2x squared minus 3 equals 7x. We need to have everything on one side. So we'll have 2x squared minus 7x plus 3 equals 0. But we also need that x squared term to have a not have a 2 in front of it. It has to kind of be a 1. So what we're going to do is we're going to actually factor out 2. We'll make this a little bit harder, especially since the 7 is not even. But when we only factor out 2, we only factor out from the first 2 terms. So you can actually add a 3 over if you want. That way you're only factoring out from those 2 terms. Now we complete the square, but only with inside the parentheses, but we got to keep in mind when we add the 3 to the other side, this is multiplying by 2. So half of 7/4, or half of 7/2 is 7/4. So we're going to end up with x minus 7/4 squared. We have to add 7/4 squared to both sides. So that would be 49/16. So we're adding, well, wait, hold on. I think about this for a second. Well, let me not skip this step. Write this out. So 2x squared minus 7/2 x plus 49/4. Right. So we're multiplying this. We're adding 49/4, but we're not really adding 49/4. We're adding 49/4 times 2, because this is going to distribute to that. That 2 is going to distribute to it. So we have to also add in 2 times 49/4. This section then boils down to what I had before, x minus 7/4 squared times 2. And then this, we can find a common denominator. I'm also going to divide the 2 into 4. And the common denominator then be 6/2. That way I can get 55/2. So now we have to solve this. Divide the 2 over. 55/4. Take the square root of both sides. Divide it over here. X minus 7/2, or say x minus 7/4, equals square root of 55/2. And then, plus or minus, then add over the 7/4. X equals 7/4 plus or minus square root of 55. That is a bit of a harder one, because not only do you have an odd b term, you have a 2 multiplying the x squared. Next one's a little bit easier because you have an even b term, but we have a 3 multiplying x squared. So what we're going to do is we'll factor out the 3 from just the first 2 terms. So 3 times x squared plus 2 times x. That's 5 equals 0. Then half of 2 is 1, and you're going to square it. Add 1, add these parentheses. But we're not just adding 1, though, we're adding 3. Where I have to add 3 to the other side. Right, so now We'll have this 3. This becomes x plus 1 squared. And we'll add the 5 over to the other side to get 8. Okay, so now solve this. Divide by 3. Take the square root of both sides. We're going to break this down. So 8 is 4 times 2, so this will be plus or minus 2 square root of 2 over square root of 3. Okay, that 3 is under the square root as well. I also want to multiply this by square root of 3 over 3 to rationalize it. So it'll be plus or minus 2 square root of 6 over 3. Now we'll solve this for x. X equals -1 plus or minus 2 square root of 6. Alright, in the second part of this, we're going to look at the quadratic formula. I'll see you then.